In this video, I am going to share the series combination of capacitors. First of all, let me share what is the meaning of series combination of capacitors. Then I will derive an expression for a capacitor that is equivalent to series combination of a number of capacitors. So what is the meaning of series combination? Suppose this is a parallel plate capacitor. Suppose we have three parallel plate capacitors. C1 is capacitance of first capacitor. Suppose C2 and C3 represent the capacitance of these three capacitors. When one plate of first capacitor is connected to plate of capacitor second C2, and this plate of second capacitor is connected to plate of capacitor C3. This plate is connected to positive terminal of a battery, and this terminal of last capacitor is grounded. This combination is called series combination of three capacitors. Now let us see how does this combination work. When this positive potential is applied to this plate of capacitor C1, then this first plate will get positively charged, and on this plate, due to electrostatic induction, a negative charge is developed on the inner side of the plate and a positive charge is developed on the outer side of the plate. Now because this outer surface is connected to next plate, so this positive charge will flow towards this plate and this plate will become positively charged. Again the same process will be repeated. Inner surface of the second plate of C2 will be negatively charged and the outer surface will be positively charged. Magnitudes of all the charges will be same. If this charge is plus Q, this plate will have minus Q. Similarly, this plate will also have plus Q, this will have minus Q. Means two plates will be equally and oppositely charged. Next, this is connected to plate of C3. So this positive charge will flow towards this plate and this plate will be again positively charged and inner surface of the plate will be negatively charged with the same magnitude plus Q and minus Q. Plus Q charge developed on the outer surface of C3 capacitor will flow towards ground. So this is how this series combination of capacitors functions. Now we have to derive an expression for total capacitance of these three capacitors when these are connected in series with each other. For that purpose, let me suppose V is the total potential difference between this terminal of first capacitor and this terminal of last capacitor. So this potential applied to the combination will be divided into three parts. Let me suppose V1 is potential that is developed across the plates of C1 and V2 is the potential developed on the plates of capacitor C2, and lastly let me suppose potential across capacitor C3 is V3. So the applied potential V is divided into three parts. Mathematically I can write V is equal to V1 plus V2 plus V3. Now by using the definition of capacitance, we know capacitance is defined as charge divided by potential. So this relation can give us a result for V is equal to Q upon C. Using this idea, I can replace V1 by Q upon C1. Charge on the plates is Q. C1 is capacitance of first capacitor. Similarly, I can write Q upon C2 in place of V2 and Q upon C3 in place of V3. Let me call it equation number 1. Let me suppose C is capacitance of a capacitor that is equivalent to the series combination of three capacitors. It has two terminals. Suppose it is connected to the same potential V. So same charge will be supplied by positive terminal of the battery and this terminal is grounded. As I have earlier explained, this plate will get positively charged by electrostatic induction. Negative charge will be developed on this face of the plate and positive charge will be developed on the outer face. Because it is connected to ground, so this positive charge will flow to ground. So we have two plates, one has positive charge Q, another have minus Q charge. Now we have to write expression for potential as we have done earlier. Potential can be written as Q, charge on the capacitor, divided by its capacitance. So this is equation number 2. So equation number 1 and 2 both are giving us the value of potential V. If I compare equation 1 and equation 2, I can write Q upon C equal to Q upon C1 plus Q upon C2 plus Q upon C3. After simplifying, I can write 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So this result shows that reciprocal of capacitance of equivalent capacitor is equal to sum of the reciprocals of capacitances of various capacitors connected in series. Means reciprocals of the capacitances get added when we connect a number of capacitors in series with each other.